Hi guys. Oh, bright light. My name's Michael Hughes. I'm going to talk a little bit about what my current role at Bizarrevoice is and the journey that we've had towards our microservice architecture that we're still developing at the moment. So, just in case you don't know who I am, I'm Michael Hughes. I'm a staff QA engineer at Bizarrevoice. And in case you don't know who Bizarrevoice are, we are very big into consumer-generated content, so reviews, ratings, things like that. We are the 7th most trafficked site on the internet normally, and pretty much the biggest over the Black Friday sort of like holiday period, just with all the reviews and ratings that go through us. So just a little bit about the team and the product that I'm working on at the moment. So who here doesn't like free stuff? Good. I did notice hand go up at the back there. Basically, the project that I'm working on at the moment is to do with sampling. So if a brand wants to get a new product into the market, the easiest way for them to get reviews is through sampling, so giving away free stuff. The way they do that is they come to us, we manage a community for them, and we can say, for instance, you don't want to give somebody a barbecue who doesn't have the space to use the barbecue. It's pointless, so we have this idea of segmentation. So you can see on the right hand side here a little brief snippet of what segmentation is. So we will allow the clients to target their free samples at specific parts of the community. Say for a barbecue, if you input on our survey that you have a garden, you're more likely that we'll target a barbecue at you, and in reply for the free sample, we expect you to give us a review. So it's very important for the clients to actually get those new reviews in there. And we have a product called Goldrush, which is our existing application. Why call it Goldrush? Well, as you can imagine, when a campaign's launched, first thing everybody does is goes and tries and gets that free stuff. So traffic's incredibly bursty. We have a lot of clients who use this, so you can imagine the traffic is very, very bursty. If a client has a lot of campaigns going on at the same time, we get incredible spikes in traffic, but most of the time it's very, very quiet. So it's that idea of that rush to get the free things. Now, Goldrush is an old monolithic application. It was written as a proof of concept and the victim of its own success in some ways, in that it's a single tenant application. So every single one of our roughly 250 clients who use this have their own instance. Now those instances have to be scaled for the bigger clients. Smaller clients, it's not too bad, but for the larger clients, we have to be able to dynamically scale that. And it's a nightmare to do it. So say it's a victim of its own success. It's proof of concept. So the team that I'm on, we're writing something called Sampling 2.0, which is to replace Goldrush, and we've decided to go down this route of microservices. So why microservices? Well, part of the answer to that is that with a monolithic application, it is incredibly hard to understand the whole application at once. So one person isn't going to know that whole application, not going to be able to reason about that whole application at once. With a microservice, very small services, single responsibility, very easy to understand on their own. It doesn't reduce the complexity of the overall application. In fact, in some cases, it can actually make it more complex and make it more difficult to reason about the application as a whole. But as far as the actual individual pieces go, they're very, very simple, very easy to reason about. And it's that trade-off in complexity and other things, which I'll get into a little bit later, that allow us to go down this microservices route and hopefully make that a success. And so far, it is proving to be that. So microservices are independent and interdependent. They're independent because if you write them correctly, they don't rely on each other for their own function. They are completely self-contained. Our architecture has a Node.js microservice with a MongoDB backend, and it talks to an SQS queue or emits change streams through MongoDB. So they're the inputs and outputs from our services. They're interdependent because one microservice by itself doesn't make an application. So they're interdependent because as a whole, they need to replicate the function of these old monolithic applications that we're trying to replace. So we use in our architecture, we have an API facade front end, which is responsible for sending commands off to each of the individual microservices. And that facade itself is a microservice. It literally takes requests from the external web, turns it into a command that is then pushed onto a queue for our internal services to actually work upon. And we have a view service, which again, the API facade acts as a proxy for the view service to actually get data back out for the client. And this is one of the big advantages that we're finding, and in replacing Goldrush with something 2.0 in the microservices, is scalability and resilience. So with Goldrush, to scale Goldrush, you basically have to replicate the entire application. And it's a big chunk of application. It takes a while to spin up. It doesn't scale particularly well across load balancers and things like that. With the microservices, what it allows us to do is find out which parts of our application are actually being hammered the most, which parts of our application get the most traffic, need to be scaled out. So for instance, if we have this Goldrush of people coming in, the service that is responsible for that will actually automatically scale, but it won't affect any of the other services. The other services will stay the same size because they don't need to scale out. So it gives us that granularity of being able to scale the services. Another big advantage is in the resilience. So there's two kinds of resilience we're getting from this. One is that because of the architecture we're using with our clustered architecture, we have multiple copies of the microservices running at any one time. But the other level of resilience we're getting from that is that if one of those microservices, even in a single instance of all of our microservices, if one of those services falls over, it doesn't affect the others around it, so that it's only that one particular small piece of functionality that no longer works. Again, that's the big advantage of the microservices. And so how do we deliver this? Well, you can imagine with a lot of moving parts, it's very, very difficult to come in and test that. So we have a continuous quality pipeline, as we call it. So we have CI/CD, which actually allows us to constantly monitor and deliver our microservices. At the moment, it only goes into our QA environment. We're not in production yet because it's still a nascent project within the business. So with the continuous quality, as the services change, it means that the changes are constantly pushed into our QA environment so that other teams can actually come in and test those for us. And as far as the testing goes, testing is like an onion. It has layers. So we start really simple with the unit tests. Thankfully, the guys that I work with, the developers that I work with, are incredibly good at writing their own unit tests. I don't really have to do anything other than make sure the coverage is correct and that the read through the unit tests, and it's great. So building up from the unit tests, we have this concept of local integration tests. As I said earlier, we have our microservice with a MongoDB backend and an SQSQ and change streams coming out of the MongoDB. So we need to do some local integration testing on those to make sure that the libraries we're using, our code for actually talking to our database and doing our transformations on the view side and actually pushing that into our denormalized views on the view side actually works. So we have some local integration testing that we do with that. And then that leads on to this idea of contract testing. So it's kind of an equivalent of the old-fashioned end-to-end tests. For a monolithic application, it's testing the endpoints of the actual microservice itself. So testing that the commands that come in are the correct commands, that if we fudge the data in the commands, the microservice reacts correctly to that and doesn't fall over, and that the information coming out of the change stream at the bottom of the MongoDB is actually correct, forming a contract that microservice says, right, this is what I accept, this is what I'll spit out, so that any other service that we're using to interact with that service, for instance our view service on the other side, knows exactly what is coming in and out of that service. And then we do have the end-to-end tests as well, but those end-to-end tests actually test our entire stack. Our whole microservices infrastructure is tested by our end-to-end tests. So they're longer running tests, they're based on user journeys. We have a very, very good UX engineer who has actually gone through and spoke to our clients and found out what they use, so we're basing our end-to-end tests on those user journeys. At the moment we don't have many because we don't have all the functionality there, but we do have a very long running test that actually hits every single one of our services when it runs. And if this join the cloud thing would stop popping up, would be nice. And next slide, please. Why are you not going on to the next slide? Come on. Yes, there we go. So, yes, so tools. So, obviously, you need the right tool for the right job. Because we have a lot of moving parts, it's very difficult to actually sit down and figure out that this one tool will do this job. We've put a lot of effort into actually finding these tools and making them work for us. So just to go through a list of the ones that we have. I do have logos on the next screen. So we use Kubernetes, is where all of our microservices sit. We use Docker containers, which is hosted within our Kubernetes cluster. We have Redis, MongoDB, all of our things are written in Node.js, that's all hosted in AWS. So why Jenkins as well? Jenkins is scriptable, it's open source, it's great active mature community, the plugins are mature, and our particular instance runs inside our Kubernetes cluster. All of our stuff is self-contained within the Kubernetes cluster. We use the Kubernetes namespaces to actually separate the Jenkins instance, which runs all of our testing, from our QA environment, which is where our end-to-end tests run. Docker, again, why use Docker? It's reproducible. It's the same all the way from the developer's laptop into our Kubernetes cluster. We use the same images, we use the same virtualization right through from our developer laptop right into our QA environment, and it will continue on into production as well. The artifacts that we produce in our QA environment will be used in production. They will not change. And it's great because it has layers. So with the way we've chosen to test this is that we build a production-like image and add a test layer on top of it. For those of you that don't know, Docker actually builds everything in layers. So by adding onto the production-like image, we can actually then test exactly that production image by adding test layer on top of it, and then that becomes our production artifact going forward. We use Kubernetes for its scalability, its flexibility. There's no vendor lock-in with it. It works in AWS. We can move to Google if we really want to. There's no plans for that, but we can run it anywhere. It's an open system. It uses the Docker containers again that we can produce on our own laptops if we want. All of our images are stored in Amazon's ECR. I was going to say ECS, but we don't use it. ECS, we use only the ECR part of it to store our images. Work inside the VPCs for hosting, and we use Elasticache, which is where Redis comes in. So we have a Redis backend for a couple of our services that need that little bit more performance than Mongo can give us. And we've spent a lot of time actually scripting this. So if like somebody did at some point, the sampling 2 namespace gets deleted from Kubernetes. Yes, I did do that before we actually introduced role-based access control. It took 2 or 3 hours to actually get that back up and running. And that included actually deploying all of our services and recreating our Jenkins namespace as well. It just means that things are very, very easy to get back up and running. So overall, this makes the reason we've chosen these tools is because we can script them. It makes it reproducible. It makes it scalable. It's quite a nice system. So tribulations. What are some of the bad things that can happen with microservices? Well, one of them is microservices sprawl. Too many small pieces. That then leads on to this far more complex overall system than you would have had if you had a monolith. We're trying to be very, very careful with the way we do that. For instance, we kind of use CQRS principles, so we kind of have command services on one side and view services on the other, but we only have one view service that actually denormalizes everything. Strictly, when you use that particular microservices infrastructure, every single one of your views should have its own service. That is too much for our application. We don't need that. The view service is performant by itself. We don't need that. We don't need that level of redundancy within it. So with our whole infrastructure, there's been a lot of effort put into actually making this scriptable. Our Jenkins is all pipeline as code. Our infrastructure is all infrastructure as code. So every single one of our microservices can be deployed from within its own Git repository on GitHub, and the information for doing that, the instructions for doing that, are stored within our code. As I said, accidents do happen, so we have gone through a lot of pain to get here. Jenkins, with its Groovy scripting and its documentation, when we first started doing this, the documentation for especially the likes of the Kubernetes plugin was awful, woeful. It was incredibly hard to actually figure out how to use the Kubernetes plugin within the Jenkins Groovy scripting pipeline. Thankfully, these days the documentation is far, far better. They've put a lot of effort into actually doing that. It's great for giving us rapid feedback as well. I think our entire test suite, if all of our services are deployed, would take less than 10 minutes to run. And we have 9 services at this point, maybe 10. But we use it for all of our shared libraries as well, so our one Jenkins instance does everything for us. Why use AWS? Well, again, going back to this issue that we had with me deleting the namespace, the role-based access control is built into Kubernetes. Kubernetes understands AWS's role-based access control with the right configuration. So it gives us that for free. We don't have to worry about it. It has role-based access to all of our repositories. It has role-based access to all of Amazon's other services. So it has permissions to set up queues. It has permissions to tear down queues. It has permissions to our Cognito-backed authentication service. It has permissions to the ECR repos, so the container repositories stored in Amazon as well. We did look at alternatives. Cost becomes a factor quite quickly. Within Bazaar Voice, we use AWS quite a lot, so we have a fairly good deal with them. So we can cut costs by using this. Again, with the monolithic service as well, the microservice cuts cost again because we're designing it multi-tenant. So we don't have to have 250 instances of it. We have a Kubernetes cluster that currently in our QA environment has 3 nodes, and it's quite happy. And it means it's very scalable in production as well. We have a lot of expertise within Bazaar Voice in AWS, so why not use that, leverage it. We have really, really good guys who know AWS inside out, they know Kubernetes. So we went down the route of, well, what are the alternatives? They're not necessarily the best. We looked at alternatives to Jenkins as well, and again, cost becomes an issue with that. And some of the other alternatives out there don't give us the flexibility that Jenkins does. One of the things we did try originally was using, Bazaar Voice has a managed infrastructure, which has its own Jenkins instance. We looked at that and asked whether we could have our set of plugins installed on that, and it turned out no, we couldn't, because some of the dependencies that our plugins needed broke other people's plugins that they were relying on specific versions of Jenkins plugins. So we decided to just roll everything into our own Kubernetes cluster, manage our own infrastructure, and that gave us a really good start. And to be honest, we're not there yet. There are so many things that we can add to our pipeline. For instance, our end-to-end tests run on a timer. We don't want them to run on a timer. We want them to run when a new version of our service is actually published into our QA environment. In fact, before it even gets there. So we're working on actually spinning up a temporary namespace with our entire stack so that we can run our end-to-end tests on a more on-demand basis. We're not in production yet, so we need to figure out how to get it into production. Do we do blue-green or black-red deployments? We don't know, but again, with Kubernetes, it gives us the option to do that very, very easily, because with the replica sets and everything in Kubernetes, we can say we want this version to have 20% of the traffic as it's deployed, and once it's proven stable, we'll turn that up to 100% of the traffic and keep the rest of the traffic going through the old stack. Very, very easy to do that in Kubernetes. Again, we're not 100% certain that we're going to do an entirely automatic release to production. It may be a scripted push button release, but that's decisions that we have to make. It's a journey towards how we get to this idea of production. One other thing we're looking at is load testing, which I'm working on at the moment. So we need to identify the bottlenecks within our microservices, which we haven't done yet. Again, we're still working on a lot of the functionality. We need to do this idea of chaos testing. So what happens if we rip a service out and just kill it, just see what happens, kill a node, whatever. There's tools out there to do that. And it's those kinds of things that we need to do. So we're still on the journey. We're not there yet, but we're getting there. And if anybody has questions, I'm open to.
Are you using anything, or have you implemented any form of distributed tracing across the microservice architecture?
We actually have a correlation ID that follows the transaction right the way through all of the services. So that was put in a few months ago, just so that we can actually track, or when this command comes in, what actually does that spawn off. So we do have some form of tracking through.
You talked about using SQS. Is much of your infrastructure tied to Amazon? Could you work with one of the other cloud providers, or are you very much a bespoke deployment?
We've tried to be as agnostic as possible. We're using the tools that are standard within Bazaar Voice, so the likes of SQS, but yeah, we can. It's just it's a shared library client that we have that can quite easily be replaced to actually just use a different kind of queue. For instance, a lot of our integration testing is done using local stack, which replicates SQS using Elastic MQ. So,
have you looked at EKS yet?
Yes, it's not suitable for what we're trying to do with it. It's not mature enough, and there's a few issues with the way the masters and the etcd actually implemented that. We're not sure yet.
Something like that kind of steer on a number of events if you look at stuff like Kinesis in your instructions?
Yes, we have. Man sitting 2 rows behind you has looked at that. So if you want to talk about that, I'd talk to Igor sitting 2 rows behind you.
If that's it.
Oh, one more.
Do you see any system monitoring, any dashboards or live metrics?
We actually have, our DevOps engineer has actually just put that in place. We're using Prometheus and Datadog, I believe, to do that. So we have a Kibana dashboard and Elasticsearch stuff as well, so that we can actually monitor all of the services. It's in its early nascent days because, again, it's a new project within the company. So we're learning, a lot of us are learning this stuff as we go on.